Hi, and welcome to the second part of our discussion, which involves the manual cell count, specifically the red blood cell count. So, for the principle, whole blood is diluted with an isotonic solution to maintain the integrity of red blood cells and to lessen their number for easy counting. Of course, this requires dilution. So, the bead, if you remember, I showed you kanina the red blood cell thoma pipette. No, there was a red bead and the bead will help mix the specimen. Then it is placed into a hemocytometer and then eventually read microscopically. So the same principle will apply with all samples, but they will vary in dilution, dilution factor, and area. So if we recall our discussion earlier regarding the hemocytometer, so the hemocytometer is divided into 9 large squares. For the four large corner squares, this is where our white blood cells are counted. And in the central square, this is where our red blood cells are counted. But to be more specific, inside the five or inside the central square, there are five intermediate squares or secondary squares. You can see here where there is a marking of letter R is where we count our red blood cells. So this side, this side, this side, this side, and this side, a total of five secondary squares. And still, the central part of the hemocytometer will still be utilized also for platelet counting. But still, we have to remember that specifically we count our red blood cells only in this or in these areas. Next, there are rules that we have to apply before we can proceed with manual cell count. First, we have to check the cell distribution among squares. So, for example, we are going to five or we are going to use the five squares. We have to check if the distribution is acceptable or not. So, less than 20 cell difference is acceptable. So, how do we do that? First, we have to identify how many cells are counted for each square. So, let's use this example here in the side. Let's say, for example, in square 1, we are able to obtain 8 cells. For square 2, we are able to obtain 15 cells. For square 3, we are able to obtain 22 cells. And for square 4, we are able to obtain 11 squares. And lastly, for square 5, we were able to obtain 25 squares. So it's very, very simple for you to identify the difference. What we do is we simply subtract the highest number of cells from the lowest number of cells. So that would be from square 5 and square 1. So we simply subtract 25 minus 8 and we get 17. So 17 is less than 20, therefore it is acceptable. But remember that we have to perform this 2 times because we have 2 areas for the hemocytometer or we have 2 chambers. Okay. Next, once we are able to check that our cell difference is acceptable for both areas, we can then proceed with the allowable difference between the chamber counts. It is also easy to perform this because there is a formula for us to identify if it is allowable or if it is accepted. Please remember that we are only going to accept if the range is within 10%. So how do we do this? For our formula, for us to get the difference, the formula is difference between two counts divided by the average number of cells in two chambers divided by 100. Let's use this example here below. So let's say for example, in chamber 1, we are able to obtain a total of 450 cells. And then for chamber 2, we are able to obtain a total of 424 cells. Let's follow the formula. So for the first one, the difference between two counts. So let's subtract 450 minus 424 and we are able to get 26. Kindly remember or take down notes and I hope you're following using your calculator. Next, it is asked for us to get the average number of cells in the two chambers. So for us to get the average, we simply add 450 plus 424 divided by 2. and we get 437. Now we simply have to divide 26 divided by 437 multiplied by 100, which is constant. We get 5.95, or if we round off up to the whole number, it is 6. That is 6%. So it is within 10%, therefore it is acceptable and we can proceed with our manual cell count. So again, class, we have to remember that we have to check the difference and the allowable difference between the squares and between the two chambers for us to really validate our results. If these do not pass, we simply repeat the procedure as there is the possibility of an even distribution for each square or for each chamber. Next, for the standard RBC count, we have to remember a lot of values. But it is very easy for us to remember the values if you have listened to our discussion prior to the manual cell count. Okay, so for the first part, it is very important for us to remember the depth of the cover slip from the grid lines or from the counting chamber itself. Remember that the depth is zero point 0.1 millimeters. So we have settled this a while ago, and I hope that by now that you memorize it by heart that the distance or the depth is zero point 0.1. So just to give you an example, or just to give you a side view, this is how it looks like. So this is the cover slip and these are the grid lines. So it is a total of zero point 0.1 millimeter. Okay, next, the area of one RBC square. So again, in the central square, we are going to count 5 intermediate squares. 1, 2, 3, 4, and 5. Okay, so now it is as the area of, or it is, we're trying to identify the area of one RBC square. Meaning to say, tinatanong ang size ng iisang square na ito. Okay, so the size of this one is equal to 0.04 millimeter squared. So this is 0.04, 0.04, 0.04, 0.04, and 0.04. Okay, so that is the area of 1 RBC squared. But of course, if you are asked if what is the area of these 5, diba, pwede mo siyang i-multiply. But again, we are not going to ask that. We are going, or we are focused only in one area, or what is the size of 1 RBC square. Okay, next, the number of squares counted. So this is also easy to remember because we know that we are only going to count in 5 squares, in 5 intermediate squares. We already know where and we already know how much. Okay, so we know that we are going to count in the central square, right? And we know that we are going to count in the 5 intermediate squares wherein they can be found here, 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 and here. Okay, so now that we know the area of 1 RBC square and we know the number of squares that we are going to count, therefore, we can calculate, or we can find out what is the total area counted. So the total area counted is simply multiplying the number of squares counted multiplied by their size. Okay? So that is the total area counted. Ganon kalaki ang binilang mo pag pinagsama-sama silang 5. Okay? But unfortunately, hindi natin pwede bilangin ng magkakatabi yan, no? Ang gagawin na lang natin, we have to apply this formula for us to identify what is the total area counted. So 5 times 0.04, we get 0.2 millimeter squared. Okay, so that is the total area counted. That is kung gaano kalaki ang area in which we were able to count the red blood cells. Okay, next. Since we know the total area, now we have to identify the volume counted. So for the volume counted, the formula is the area times the depth. As simple as that. Okay? So, bakit ba kailangan natin yung depth? Kasi po, dito po pumapasok ang ating sample. And that sample is liquid. So, we have to identify ano ba yung volume. 'Di ba? What is the volume that we used for counting? Okay? So, the area counted, which is 0.02, multiplied by the depth, 0.2 pala, multiplied by the depth, which is 0.1, is equal to 0.02 millimeter cubed. Okay? So that is the volume counted. That is the total volume that we were able to count under the cover slip up until to the grid lines. Okay? So, in my opinion, as long as you know the depth and as long as you know the size of the 5 red blood cell squares, you are good to go. Okay? So, it doesn't stop here, no? We have other values that we also need. So, ma'am, why do we have to remember these values? Given po ba yan or hindi? So, it is possible, class, that there are situations or there are cases that you have to compete for these values na kasi it's not constant that they are given. Okay? Pero it's important that we know how to compute for this because once we know how to we know how to identify these values, it is very easy for us to apply the formula in identifying the red blood cell count itself. Okay? So, first, let's talk about the dilution. Kanina, when we were talking about the red blood cell thoma pipette, I talked about the dilution. If our dilution is 1 is to 100, we fill up the blood up until the 1 unit mark and then continue filling up with the dilution fluid or diluting fluid up until the 101 mark. Diba? Natatandaan po natin yan. But I also mentioned earlier that the standard dilution factor for red blood cell count is 1 is to 200. Okay. Now, if we are going to talk about the 1 is to 200, if you remember our RBC thoma pipette, hanggang saan kasi natin siya i-fill up? Up until the 0.05 or the 0.5 unit mark only. No? I'm sorry if that is the 0.5 unit mark only. And then we continue filling it up until the 101 mark. Okay, so again, that is when our dilution is 1 is to 200. Next, the dilution correction factor. For the DCF, this is just the reciprocal of the dilution. So what we do is the total volume of blood, which is 100, saan po natin galing yung 100? Okay, so the 100 is the total volume. Okay, sorry. Again, the 100 is actually the total volume. If you remember, balikan natin, no? Let me go back to the slide para mas madali. Ayan. So, kanina, you can see that in the red blood cell pipette, sabi, no, it can contain larger dilutions. So, kaya niya hanggang dito sa 101. Pero class, I want you to remember that even though 101 ang nakasulat dyan, the total volume here is only up until 100. Okay, pampalito lang yung 101 na yan. No? We have to remember that it is up until 100. No? Para hindi tayo malito. Yes, it can dilute, it can perform higher dilutions up until the 101 unit, but the total volume of this is just 100. So kanina, ang sabi ko, the standard solution or the standard dilution for red blood cell is 1 is to 200. So we fill up the blood up until here, and then we continue filling it up with the diluting fluid up until here. Therefore, this one, when we get the total volume of this one, that is 100. Okay, so we can apply it now here. So the total volume, that is 100 divided by 0.02 Saan nanggaling yung 0.05? Kanina, dun sa blood na nilagay natin up until the 0.5 unit mark only. So if we divide 100 divided by 0.5, it is equal to 200. So actually, kabaligtaran lang siya ng dilution talaga. Pwede mo nang angkunin, pero hindi tayo nag-shortcut. We have to double check kasi hindi natin alam, baka merong pampalito dyan or merong mga, um, merong mga discrepancies dyan. We have to always perform or we have to apply our formulas. Okay, so again, the dilution correction factor or the DCF is that we have the formula total volume divided by the volume of blood. The total volume is 100 divided by 0.5. Okay, next we have the VCF or the volume correction factor. So in this cell counting process, we are working with a volume of 1 millimeter cubed within the hemocytometer. So the volume is determined by the grid area we are using and the depth of the chamber. So in this case, the depth of the chamber is still 0.1 millimeter. That is constant class, hindi po magbabago yon. But the area we are counting covers enough grid space to give us a total volume of exactly 1 millimeter cube. Okay? So because we are using 1 millimeter cube, we don't need to do further volume corrections when calculating the cell concentration per ml. Okay? Bakit? Because 1 millimeter cube is equal to 0.001 ml. Since 1 ml is equal to 1,000 millimeter cube, the volume we are counting, which is 1 millimeter cube, is equivalent to 0.001 ml of the sample. So, in-explain ko lang naman actually kung bakit 1 millimeter cube ang nandito po sa desired volume natin. Ibig sabihin kasi nito, this is the volume that we're trying to get. Kaya nga siya desired volume. Okay? So this is what I'm referring to. It's not always that, for example, in the formula, the VCF is required. What if hindi given sa solution ang desired volume? Therefore, we cannot compute for the VCF. 'Di ba? So it's important that we know how to get all the specific different values so we can apply it when using the formula. So I know it's still a little confusing right now. Later I will show you what I'm trying to say. Okay? But first, let's focus with this one first. So again, we have the volume correction factor. For the volume correction factor, we have the following formula. So desired volume over the volume counted. So the desired volume is 1 millimeter cubed divided by the 0.02 millimeter cube. Okay? So, saan po natin galing yung volume counted na to? Kanina po, doon sa una nating table. So, for the volume counted, again, paano po natin nakuha yan? That is the area counted, which is 0.02, times the depth, which is 0.1. Therefore, we are able to get 0.02 millimeter cube. Okay? So desired volume, that is 1 millimeter cube divided by 0.02 millimeter cube. Of course, we are going to cancel out the same units. Therefore, we get 50. Okay? So our VCF is 50. All right? So I hope that is clear. So we have our multiplying factor. This one is very easy since usually the DCF and the VCF are constant. Usually po, not always. Therefore, we already have an automatic multiplying factor, which is the VCF times the DCF, and that would be the 10,000, the value 10,000. So the VCF is this one, 50 multiplied by 200, it is equal to 10,000. Okay? And then, when we have the area or when we talk about the area factor, this is just the reciprocal of the total area counted. Total area counted po is 0.02. Babaligtarin lang po natin yun, no? When we say reciprocal, so 1 divided by 0.02, that is 5. 1 divided by Yan. 1 divided by 0.2 is equal to 5, and the depth factor is the reciprocal of the depth, that is 1 divided by 0.1, that is 10. Just to let you in on a secret, when we have or when we see the word factor, dito po ha, except for the DCF and yung mga may correction, hindi po natin pwede apply ito. But when we see this one, the correction factor, actually pwede kay DCF din, no? Except for VCF. When we see, yan, DCF factor, area factor, depth factor, it is only, or it is usually just the reciprocal of the value being asked. So, tulad dito, ano ba yung dilution natin? Again, the standard dilution is 1 is to 200. Pag sinabi nating reciprocal, babalik na rin lang natin. Di ba? And then, for example, here in the area, alam natin the area factor is 0.2. We just simply, babalik na rin lang natin siya. Okay, we divide, it is usually 1 divided by 0.2. Okay, and then for the depth factor, since we know that this is 0.1, usually babalik na rin nga lang dan natin yan, lalagyan lang natin ng 1 divided by 0.1. So, yun yung mga shortcut natin. Pero again, these are just ways to do it a little more convenient. But still, it's important that we know how to get them. Okay? So, eto na po yung sinasabi ko. Look at the formulas that we have for the red blood cell count. Okay? So, for the first formula, these are the values that we need. We need the dilution factor, we need the area, we need the depth, and we need the volume. So, we directly apply all of these into the formula, and then we get our red blood cell count. As simple as that. Okay? So, for example, in this formula, itong mga naka-highlight na ito, these are the formulas that are written in RODAX. Okay? You can actually use all these kung anong pinakamadali para sa inyo. But of course, if you are required to use a specific formula, it's good that you memorize all of these formulas na lang. Okay? But again, you can use either. Look at this one. It is very, very easy. Okay? We just simply multiply the number of cells counted multiplied by the DCF times the VCF, or simply the multiplying factor kanina, which is 10,000, and then we get the red blood cell count. However, it is not always constant that we can able to get the DCF and the VCF. Diba? So, it's important that tulad nito, we know the dilution factor. We know the area. We know the depth. We know the volume. Ito, we don't need to do anything, or we don't really need to figure out anything. We need to simply apply kung ano ba yung mga values na alam na natin. We know that the dilution factor is 200. We know that the area is 0.02, or sorry, 0.04, and we know the depth is 0.1, and we know that the volume is 100. Diba? With that, we can simply use this formula. And then for this one, you can see that the values needed are the area factor, which is the reciprocal of the area, the depth, which is the reciprocal of the depth, and then the dilution factor, which is also the reciprocal of the dilution. Diba sabi ko nga, as long as you see the word factor, binabaligtad lang yan. Okay, binibigyan lang natin yan ng 1 divided by the value. And since you know how to use that, therefore, you can apply this to this. Okay? So, actually, hindi na ako magbibigay ng sample calculations because mas marami kayong ganito when it comes to your lecture. And of course, we will apply this directly once we have our experiment. So right now, it's important that you just know what are the formulas available, or what are the formulas you can use in our experiment. So I hope you reach this discussion up until the end, and I hope you are able, or you can apply everything that you learned during our discussion. These are my references for my discussion. Thank you so much for listening. If you have any questions or clarifications, of course, please do not hesitate to ask during our discussion, or you can reach out online as well. Have a great day ahead, and thank you so much again for listening.